Hi guys, this is Vineet and I welcome you to this video. Today's video topic is we will discuss about concepts related to index fragmentation and page density in SQL Server. Before we proceed ahead, I would request you guys to please go ahead and subscribe to this channel immediately. There's a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding my future and all the upcoming videos. The reason I'm asking you to subscribe is because I don't want you to miss on any of the indexing related videos that I will be releasing in the upcoming 10 to 15 days. And I want you to subscribe to my channel because I don't want you to miss on any of the notifications that you will receive if you subscribe to my channel. So please go ahead and subscribe immediately. There's a subscribe button below this video. Click on the subscribe button and follow the process. I'm waiting right now. I'm giving you 5 seconds. Please go ahead and subscribe right away. So guys, I hope you must have subscribed by now. So let's move ahead. There are some points to remember while watching this video. Please watch this video till the end to gain better clarity of the concept. And if it's possible for you, please watch this video twice or as many times as you like until the concept gets clear to you. Perform any exercises in your test and lab environments, only do not touch any production environment or production databases. We would like to know your thoughts regarding our videos, so please do post us your comments and suggestions guys. You may also post in your stories. We have created some playlists for you to watch. Some of the popular SQL Server playlists are SQL Server database design, tables, business continuity, indexing, performance tuning, integration services, and transact SQL. And if we talk about this video pertains to the SQL Server indexing category. The reason we create playlists for you is because we feel that playlists are the best way to learn. For example, if you want to learn about any particular area, let's say, let's take an area like indexing. So if you want to learn about indexing area, what I would recommend is go to the SQL Server indexing playlist and watch out all the videos from starting till the end to gain better clarity in that area. And if we talk about this indexing playlist, it has more than 25 videos at present, and the list is growing. And if we talk about the total videos posted on our channel, it's nearly around 250 videos, so you can watch them all out, but I would recommend going through the playlist instead of watching videos randomly on every topic. It's always better to go through the playlist if you want to learn any particular topic. The slide contains my channel link page as well at the bottom of the slide. And guys, link for all these playlists and my channel page link is also given in the video description area of this video, so please check out the video description area for this video to find out all the links so that you can go there directly. Now let's come back to today's topic, which is index fragmentation and page density in SQL Server. We will talk about the concepts, and this will be a theoretical session, so let me quickly take you to notes. So today we are discussing about concepts of index fragmentation and the page density. Now in this video we will discuss about the concepts such as the index fragmentation and the page density and their impact on the query performance and resource consumption. So we will cover these two topics, particularly index fragmentation and the page density, and we will also discuss about their impact on the query performance and the resource consumption. So let's talk about the index fragmentation and how it impacts the performance. Now in B-tree indexes, or we can say row store indexes. So all our normal indexes are row store indexes. Unless we create them as column store indexes, all the indexes are row store indexes. So in B-tree structure type indexes, which are row store indexes, fragmentation exists when index have pages in which the logical ordering within the index based on the key value of the index does not match the physical ordering of the index pages. So we are talking about general indexes or the B-tree indexes. In these indexes we do see fragmentation exists. Fragmentation exists when the indexes have pages, so all the index data is stored in pages, and fragmentation can exist in pages when the logical ordering within the index does not match with the physical ordering of the index pages. When this occurs, we see fragmentation in the pages of index. Now we use the B-tree term generally in reference to the indexes. So all our normal indexes, we use the term B-tree. Now in row store indexes, SQL Server implements a B plus tree structure. We talk about the row store indexes. the SQL Server implements a B tree structure, and this does not apply to the column store indexes. So for any of the column store indexes, we will talk about them later. We will be covering the videos in the next 10 days. So the topic of column store indexes will come. So that's the reason I'm asking you to subscribe. So please subscribe right away if you have not. Alright, so let me move ahead. So the B plus tree structure does not apply to the column store indexes or any in-memory data stores. The data which gets stored in the memory, B plus tree structure do not apply, as well as for any column store indexes, the B plus tree structure does not apply. The B tree or B plus tree structure only applies for the row store indexes. Now let's talk about the fragmentation topics. So the database engine, if we talk about the SQL Server database engine, automatically modify the indexes whenever insert, update or delete operations are made to the underlying data. So whenever there is a modification to the data in a table, like insert operation, update operation, or the delete operation that occur on the data, if any changes are made to a data, the database engine automatically modify the indexes. Now if we take an example, for example, if we add any rows in a table, or if we talk about addition of rows in a table, this may cause existing pages in row store indexes to split. So whenever we add some rows in a table, and if your index page is full, this will cause any existing pages in the row store indexes to split, to make basically the room for insertion of new rows. So if your index page is full, it will get split into two pages, so that a room can be made for insertion of new rows into the index structure. Now over time, these modifications like additions, deletions, alterations can cause data in the index to become scattered in the database, which is also known as fragmentation or fragmented. So over time, modifications occur to a data, and these modifications can cause data in the index to become scattered in the database, or become fragmented. Now for queries that read many pages, so if we talk about the queries that read many pages using the full or range index scans, heavily fragmented indexes where we have large number of pages and less number of rows in each page, so those type of indexes are called the heavily fragmented indexes. So if you are using any queries that read many pages using a full or range index scan, then if you have heavily fragmented indexes, it can degrade the performance, because additional I/O may be required to read the data required by the query. So let's go through this statement again. So if we talk about queries that read many pages using the full or range index scan, if we have heavily fragmented indexes, it can degrade the query performance, because additional I/O is required to read the data required by the query. So if there are more number of pages, more I/O is required to read the data. If your page splitting is occurring, and if you have more index pages to be read, then yeah, these are called heavily fragmented indexes. And if we have heavily fragmented indexes, it will require more I/O pages to be read for returning the result for a query, and this can degrade the query performance. Instead of small number of large I/O requests, the query would require a large number of small I/O requests. So what the optimizer generally needs is, we need a large number of queries with small I/O requests, instead of small number of queries with a large I/O request, to read the same amount of data. Now when the storage system provides better sequential I/O performance than random I/O performance, so if we have a storage system or a hard disk or SSD disk, whatever we are using depending upon the storage system, whether it provides the better sequential I/O performance than random I/O performance. So it depends upon the type of storage system. Some storage system provide better random I/O performance, and some storage system provides better sequential I/O performance. So we are talking about the storage system. If your storage system provides better sequential I/O performance, index fragmentation can degrade the performance, because more random I/O is required to read fragmented indexes. So if your storage system provides good random I/O performance, then it's good. Index fragmentation will not cause an issue. But if your storage subsystem or system provides better sequential I/O performance, then yeah, index fragmentation can degrade the performance, because more random I/O is required in these cases to read the fragmented indexes. Now let's talk about the page density. Here we are talking about the index pages where the index data gets stored. So let's talk about page density and how it affects the performance. Now, if we talk about each page in a database contains variable number of rows. So a page is basically a unit of storage in SQL Server, so it contains rows either for the table or for the index. Pages exist for, there are data pages and there are index pages. So each page in database contains the variable number of rows, and if rows takes up all the space on the page, so if your rows are taking all the space on the page, which means that page density is 100%. So if your page is fully filled with rows, the page density is 100%. And if your page is totally empty or no rows are stored on that page, the density of the page is 0%. Now if a page with 100% density where the page is full of rows, this page with 100% density gets split into two pages to accommodate a new row. So if we have a page with 100% density and if we are adding rows that require insertion, that row requires insertion within the list of rows in that page, then that insertion will cause the split of those that particular page into two pages to accommodate that particular new row. The density of the two new pages is now approximately 50%. So when a page is, if a page with 100% density split into two pages, then the density of each of these new pages will be 50%. There, which means they will be 50% empty. Now, when the page density is low, which means the less number of rows are stored in a page, more pages are required to store the same amount of data. Now, here we are talking about the situation where the page density is low, or a page contains the lesser number of rows. Then we need more pages. So more pages are required to store the same amount of data if the page density is high compared to where the page density is high. This means that more I/O is necessary to read and write this data. So if there are more number of pages, we need more I/O to read and write this data, and more memory is also required to store these pages or to cache this data. Now, if your system memory is limited, fewer pages need to be cached as well on the disk, causing even more disk I/O bottleneck, right? And consequently, low page density negatively affect the performance. So if we talk about if your page density is low, it will negatively affect the performance of the query. Now, whenever a database engine adds rows to a page, it will not fill the page fully if the fill factor of the index is set to other than 100. So whenever the database engine is doing insertion into the index pages or to the data pages, it will not completely fill up the page if your fill factor of the index is, so here we are talking about the index pages particularly. So if your database engine is adding a row into the index page, and if your fill factor is set to other than 100 or 0, which is equivalent to 100, then the database engine will not fill the page index page completely if the fill factor is set to other than 100 or 0, and this will cause the lower page density and will add to the I/O overhead and negatively affects the performance. Now, if we talk about low page density, it may increase the number of intermediate B tree levels. So if we have low page density, it will increase the number of intermediate B tree levels, and this moderately increase the CPU and I/O cost of finding the leaf level pages in the index scans and seeks. Let's move on to next point. Now, when the query optimizer, if we talk about query optimizer, compiles a particular query plan, it also considers the cost of I/O needed to read the data required by the query. Now, if we have a low page density, there are more pages to be read, right? And therefore the cost of I/O will be higher. If there are more pages to be read, then the cost of I/O will be higher, on the higher side. And this can impact query plan choice by the query optimizer. So if your I/O cost is high, the query optimizer may choose a different query plan. So this can impact the query plan choice by the query optimizer. Now let's discuss an example. For example, as page density decreases over the time due to page splits. So whenever a page split occurs, the density of the page decreases. So as the page density decreases over the time due to the page splits, the optimizer may compile a different plan for the same query compared to when you have a lesser number of pages. So if you have larger number of pages, your optimizer may compile a different plan for the same query with a different performance and resource consumption profile. Now, if we talk about many workloads, increasing the page density results in the greater positive performance. So if we have a higher page density, then we have a greater positive performance impact than reducing the fragmentation. Alright, so this is one of the good points. So if your page density is high, this can provide much more positive performance rather than reducing the fragmentation. And to avoid lowering the page density unnecessarily, it is not recommended setting the fill factor value to other than 100 or 0, except in certain cases. So there are certain cases where we change the fill factor value from 100 or 0. Otherwise, it's a recommendation to keep the fill factor at 100 or 0 only. But in certain cases, we may change the fill factor values. So whenever we are experience the problem of excessive place splits, and in those cases, we may try reducing the value of the fill factor of index pages. Let's take an example. Frequently modified indexes with leading columns containing non-sequential GUID values. So this is one of the examples where we see a higher number of page splits, and whenever we have higher number of page splits, we generally see that there are frequently modified indexes with leading columns containing non-sequential GUID values. Alright, so this is one of the situations where we see where we can assume that the frequent page splits are occurring. And basically, if the frequent page splits are occurring, then we may consider changing the fill factor value. But otherwise, if the page splits are not occurring normally, then yeah, we should consider keeping the fill factor to 100 or 0. It is recommended. So guys, I hope you like the content of this video. If you really like the content of this video, please go ahead and click on the like button. There's a like button below this video. Click on that like button if you really like the content of this video. We have more videos coming in where we will show you how you can calculate the fragmentation of the indexes and the page density levels. So in our next video we will cover that. So I don't want you to miss on that video. So what I would suggest is subscribe right away. There's a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding my future and upcoming videos. And the reason I'm asking this is because I will be creating more and more indexing videos in the upcoming 10 to 15 days, and the next video will be on how you can calculate the index fragmentation and the page density levels. So that is one of the important videos to be watched, so don't want you to miss on that video. So that's why I'm requesting to please go ahead and subscribe to this channel right away. There's a subscribe button below this video. Click on that subscribe button and follow the process. So do that right away. I'm waiting for 5 seconds. Guys, please go ahead. So guys, I hope you must have subscribed by now. So if you have subscribed by now, I would request you to post in your comments and suggestions regarding my videos. We eagerly wait for your comments and suggestions, and we love to read them. And also guys, if you have a good network of friends, then I may require a help from your end. So if you have friends who also work in SQL Server domain, and if you think that my videos can make difference in their life, then yeah, you may share my videos via the share button below each video. You will see a share button below each video through which you can share my videos with your friends on any of the social media platforms. And you may also ask your friends to subscribe to my channel in case you feel my channel can make difference in their life, and my channel can help in learning and improve their life if they are dealing with SQL Server on a day-to-day basis. I thank you so much for your time on this video, guys, and you have a wonderful day ahead. Thank you.